Solve by matrix inversion method each of the following system of linear equations. 2x minus y is equal to 7. 3x minus 2y is equal to 11. X plus y plus z is equal to 9. 2x plus 5y plus 7z is equal to 52. 2x plus y minus z is equal to 0. X minus 3y minus 8z plus 10 is equal to 10. That is equal to 0. 3x plus y is equal to 4. Find the rank of the following matrices. 1, 1 minus 1, 3 minus 2, 3, 2 minus 3, 4. Find the rank of the following matrices: 3, 1, 2, 0, 1, 0, minus 1, 0, 2, 1, 3, 0. Find the rank of the following matrices: 1, minus 2, 3, 4, minus 2, 4, minus 1, minus 3, minus 1, 2, 7, 6. Solve the following non-homogeneous system of linear equation by determine method. Solve the following non-homogeneous system of linear equations by determine method. X plus y plus z is equal to 4. X plus y plus z is equal to 2. 2x plus y minus z is equal to 1. Solve the following non-homogeneous system of linear equation by determine method. X plus 2y plus z is equal to 6. 3x plus 3y minus z is equal to 3. 2x plus y minus 2z is equal to minus 3. Solve the following non-homogeneous system of linear equation by determining method. 1 by x plus 2 by y minus 1 by z is equal to 1. 2 by x plus 4 by y plus 1 by z is equal to 5. 3 by x minus 2 by y minus 2 by z is equal to 0. Solve the following non-homogeneous system of linear equation by determined method. A small seminar hall can hold 100 chairs. Three different colors, red, blue and green, of chairs are available. The cost of a chair is rupees 240. The cost of a blue chair is rupees 275 and the cost of a green chair is rupees 300. The total cost of the chairs are rupees 25,000. Find at least three different solutions of the number of chairs in each color we purchase. Solve the following homogeneous system of linear equation by determined method. X plus 2y is equal to 0. 2y plus x is equal to 0. Solve the following homogeneous system of linear equation by determined method. X plus y minus z is equal to 0. 3x plus z is equal to 0. 2x minus y plus 2z is equal to 0. Solve the following homogeneous system of linear equation by determined method. X plus 2y plus 3z is equal to 0. 3x 6y plus 9z is equal to 0. 2x plus 4y plus 6z is equal to 0. Examine the consistency of the following system of equations. If it is consistent, then solve sum of the equations. 4x plus 3y plus 6z is equal to 25. X plus 5y plus 7z is equal to 13. 2x plus 9y plus z is equal to 1. Examine the consistency of the following system of equations. If it is consistent, then solve sum of the equations. X plus y plus z is equal to 6. X plus 2y plus 3z is equal to 10. X plus 2y plus 4z is equal to 1. Examine the consistency of the following system of equations. If it is consistent, then solve sum of them. X minus 3y minus 8z is equal to minus 10. 3x plus y minus 4z is equal to 0. 2x plus 5y plus 6z is equal to 13. Examine the consistency of the following system of equations. If it is consistent, then solve some of them. X minus 4y plus 7z is equal to 14. 3x plus 8y minus 2z is equal to 13. 7x minus 8y plus 26z is equal to 5. Examine the consistency of the following system of equations. If it is consistent, then solve some equations. X plus y minus z is equal to 1. 2x plus 2y minus 2z is equal to 2. Minus 3x minus 3y plus 3z is equal to minus 3. For what values of k, the system of equations kx plus y plus z is equal to 1, x plus ky plus z is equal to 1, x plus y plus kz is equal to 1 have unique solutions, more than one solution, and no solution. Discuss the solutions of the system of equation for all the values of x plus y plus z is equal to 2, 2x plus y minus 2z is equal to 2, 2x plus y plus 4z is equal to 2. Discuss the solutions of the system of equation for all the values of x plus 2y plus 3z is equal to 0, 2x plus y plus 3z is equal to 0, 3x plus 2y plus z is equal to 0.
Introduction. We have already learnt about addition and subtraction on vectors. In this chapter, we will study about the product of two vectors. The product of two vectors results in two different ways, a scalar product and a vector product. Before defining these products, we shall define the angle between two vectors. Angle between two vectors. Let two vectors A and B be represented by OA and OB respectively. Then the angle between A and B is the angle between their directions when these directions both converge or both diverge from their point of intersection. It is evident that if theta is the numerical measure of the angle between two vectors, then 0 less than is equal to theta less than is equal to pi. The scalar product or dot product. Let A and B be two non-zero vectors inclined at an angle theta. Then the scalar product of A and B is defined by A dot B and is defined as the scalar modulus A modulus B cos theta. Thus, A dot B is equal to modulus of A modulus of B cos theta is equal to AB cos theta. Geometrical interpretation of scalar product. Let OA is equal to A, OB is equal to B. Let theta be the angle between A and B. From B, draw BL perpendicular to OA. OL is called the projection of B on A. From triangle OLE, cos theta is equal to OL by OB. Projection of B on A and projection of A on B is shown on the screen. Properties of scalar product. Property 1. The scalar product of two vectors is commutative, that is, A dot B is equal to B dot A for any two vectors A and B. The proof is shown on the screen. Scalar product of collinear vectors. When the vectors A and B are collinear and are in the same direction, then theta is equal to 0. When vectors A and B are collinear and are in the opposite direction, then theta is equal to pi. Sign of dot product. The dot product A dot B may be positive or negative or 0. If the angle between the two vectors is acute, that is, 0 less than theta less than 90 degrees, then cos theta is positive. In this case, dot product is positive. If the angle between the two vectors is obtuse, that is, 90 less than 0 less than 180 degrees, then cos theta is negative. In this case, dot product is negative. If the angle between the two vectors is 90 degrees, that is, theta is equal to 90 degrees, then cos theta is equal to cos 90 degrees is equal to 0. In this case, dot product is 0. Property 4, 5 and 6 are shown on the screen. Property 7. If M, N are scalars and A, B are two vectors, then MA dot NB is equal to MN A dot B is equal to MNA dot B is equal to A dot MNB. Property 8. The scalar product is distributive over addition. A dot B plus C is equal to A dot B plus A dot C for any three vectors A, B, C as shown above. Property 9. For any two vectors A and B, A plus B whole squared is equal to A squared plus 2AB plus B squared as shown on the screen. Property 10. Scalar product in terms of components. The scalar product of two vectors is equal to the sum of the products of their corresponding components as shown above. Property 11. Angle between two vectors. Let A, B be two vectors inclined at an angle theta. A dot B is equal to modulus of A modulus of B cos theta as shown. Property 12. For any two vectors A and B, modulus of A plus B lesser than or equal to modulus of A plus modulus of B. Triangle inequality. We know already that the scalar product of two vectors is A dot B. Using dot product, we get A dot B as 19. In this case, A is perpendicular to B. Using dot product, A dot B is equal to 0. To get A dot B value, m minus 4 is equal to 0. This implies m is equal to 4. In this case also, A dot B is equal to 0. This gives m is equal to 16 by 5. For the above example, substitute the given data, modulus A is equal to 4, modulus B is equal to 3, and A dot B is equal to 6. In the formula, cos theta is equal to A dot B by modulus A modulus B, we get cos theta is equal to 1 by 2. This implies theta is equal to pi by 3. For the above example, let theta be the angle between the vectors. In order to find theta, we use the formula shown above. Substituting the values in the given formula, we get the required angle. For the above example, we use direct formula for the sum and difference of any two vectors A and B. Let us consider equation 1 and 2. Adding both the equations, we arrive at the result. Since the values of A and B are equal to 1, the above equation is simplified to give 2 minus 2 cos theta. Applying trigonometric formula, we get modulus of A minus B the whole squared is equal to 2 sin theta by 2. This gives the result. Show that the vectors 2i minus j plus k, I minus 3j minus 5k, minus 3i plus 4j plus 4k form the sides of a right-angled triangle. The proof of the problem is shown on the screen. Geometrical application of dot product. Using formulae. Usual notations. From the diagram, as we know that AB plus BC plus CA is equal to 0, that is, A plus B plus C is equal to 0. Shifting B plus C, the whole, to the right-hand side and squaring on both sides, and also applying trigonometric formula to get cos A is equal to B squared plus C squared minus A squared by 2BC. In the same way, we proceed to get the results as shown. We have already studied in trigonometry that A is equal to B cos C plus C cos B. From the diagram, AB plus BC plus CA is equal to 0. That is, A plus B plus C is equal to 0. Multiplying with A on both sides, we get A dot A is equal to minus A dot B minus A dot C. Using dot product formula and dividing by A, we get A is equal to B cos C plus C cos B. Similarly, B is equal to A cos C plus C cos A and C is equal to A cos B. To prove the formula, take the points P and Q on the unit circle with center at the origin O. Assume that OP and OQ make angles A and B with x-axis respectively. Application of scalar product in physics. Work done by force. The work done by force is a scalar quantity and its measure is equal to the product of the magnitude of force and the resolved part of the displacement in the direction of the force. Let a particle be placed at O and a force F represented by OB be acting on the particle at O. Due to the application of force F, the particle is displaced in the direction of OA. Here, OA is the displacement and OL is the displacement in the direction of F as shown in the figure. From the above, we get work done by the force is equal to F dot D. Proof by vector method is shown on the screen. Definition. The vector product of two vectors A and B is denoted as A cross B, and it is defined as a vector whose magnitude is modulus A modulus B sine theta, where theta is the angle between A and B, 0 lesser than or equal to theta lesser than or equal to pi, and whose direction is perpendicular to both A, B, and this direction constitutes a right-handed system. In other words, A cross B is equal to modulus A modulus B sin theta n, where theta is the angle between A and B, and n is a unit vector perpendicular to both A and B in such a way that A, B, n form a right-handed system. Geometrical interpretation of vector product. Let A is equal to A, OB is equal to B. Let theta be the angle between A and B. Complete the parallelogram OACB with OA and OB as adjacent sides. Draw BN perpendicular to OA. In right angle triangle ONB, BN is equal to modulus B sin theta. The area of the parallelogram is obtained as shown above. Properties of vector product. Property 1. Non-commutative of vector product. Vector product is not commutative. That is, if A and B are any two vectors, then A cross B not equal to B cross A. However, A cross B is equal to minus B cross A the whole. The proof is shown above. Property 2. Vector product of collinear or parallel vectors. If the vectors A and B are collinear or parallel, then A cross B is equal to 0. The vectors A and B are collinear or parallel, then theta is equal to 0, for theta is equal to 0, pi. The proof is shown above. Property 3. Cross product of equal vectors. A cross A is equal to 0 for every non-zero vector A. Property 4. Cross product of unit vectors I, j, k. By the above property, I cross I is equal to j cross j is equal to k cross k is equal to 0. Property 5. If M is any scalar and A, B are two vectors inclined at angle theta, then MA cross B is equal to M A cross B the whole is equal to A cross MB. Property 6. Distributivity of vector product over vector addition. Let A, B, C be any three vectors. Then 1. A cross B plus C the whole is equal to A cross B plus A cross C left distributivity. 2. B plus C the whole cross A is equal to B cross A the whole plus C cross A right distributivity. The result for property 6 is shown above. Property 7. Angle between two vectors. Let A, B be two vectors inclined at an angle theta. Then A cross B is equal to modulus A modulus B sin theta n. Property 8. Unit vectors perpendicular to two given vectors. That is, unit vectors normal to the plane of two given vectors. Vectors of magnitude mu normal to the plane containing A and B is shown above. For any two vectors A and B, by the definition of cross product, modulus A cross B the whole squared is equal to modulus A squared modulus B squared sine squared theta. By the definition of dot product, A dot B the whole squared is equal to modulus A squared modulus B squared cos squared theta. Adding